स्ट्रेंथ ऑफ मटेरियल मेड इजी बाय एच एन शर्मा की सीरीज में आज हम स्टडी करेंगे एडवांस्ड एनालिसिस ऑफ स्ट्रेस स्ट्रेन कर्व फॉर डक्टाइल मटेरियल। लेकिन आगे बढ़ने से पहले मैं आप लोगों से रिक्वेस्ट करूंगा कि अभी तक अगर आपने इस चैनल को सब्सक्राइब नहीं किया है तो काइंडली सब्सक्राइब कर लीजिए और साथ ही साथ साइड में लगे हुए बेल आइकन पे जरूर क्लिक कीजिए ताकि जब भी मैं कोई नया वीडियो अपलोड करूं तो आपके पास में टाइमली नोटिफिकेशन पहुंच सके। Let us say we are having a specimen that we have to fit on the UTM and do the tensile test. Obviously, ये एक ductile material है. Let me draw the shape of that specimen. Ends of the specimen पे cross section area, middle पे जो cross section area है उससे ज़्यादा होगा because we have to grip the material in the machine. So here the cross section area at the end will be higher. In middle ये जो cross section area आप देख रहे हैं from here to here this is the length. This is the length on which we are having our focus. This is known as the gauge length. The cross section of this specimen, it may be circular or may be rectangular. Now we are applying the load along the axis of the specimen. This is P, this is P. Along the axis एक ही direction में हम load लगा रहे हैं. So this is the case of uniaxial stress. Now on the application of the force, obviously इसके अंदर में stresses will be induced and accordingly we are drawing our stress and strain diagram as shown by the red line in this particular figure. Now come to the diagram. It is starting at the point O जहाँ पर stress और strain दोनों की value 0 है. From the point O to A, this is the straight inclined line. A is the proportionality limit क्योंकि O से A तक आपका stress is proportional to strain. After the point A up to the point B, this is elastic limit. Means अगर आपने मटेरियल से लोड को रिलीज किया तो मटेरियल आपका ओरिजिनल शेप एंड साइज में रीस्टोर हो जाएगा. आफ्टर द पॉइंट बी, दिस इज द प्लास्टिक जोन. अगर आप फर्दर फोर्स लगाते हैं मीन्स नाउ द बॉडी इज डिफॉर्मिंग प्लास्टिकली. आफ्टर द पॉइंट बी, दिस इज द प्लास्टिक डिफॉर्मेशन. इट मीन्स दिस पॉइंट बी, ये बी पॉइंट पे दिस इज गिविंग मी द वैल्यू ऑफ yield stress sigma y. After that, this is the point C, upper yield point, D, lower yield point. Then E point पे strain hardening phenomena predominant हो जाता है and the strength of the material is increasing and it is reaching up to the point F. This point F, this is the point of ultimate stress. So I can write this is sigma UTS. Ultimate tensile stress point. So I will write it here, sigma UTS, ultimate tensile stress. Means this is the maximum resistance that the body can give to the external load. After the point F, the necking in the material will start and the material will fail at the point G, that is the breaking stress. Okay. Now let us try to derive some mechanical properties from this stress strain curve. So first one is our strength. The value of strength, it is given by the yield stress. That is sigma y, or by ultimate tensile stress, that is ultimate tensile stress, that is sigma UTS, because after that the necking initiates and the material fails at the point G. And if we are talking about the units, then it can be given in terms of Newton per meter square, and that is equal to the Pascal. Here the case. Now the second one is stiffness. Let's come to the line O to A. I am finding the slope of this line. So for that, let me draw this vertical line. This is a change in stress delta sigma, and horizontal line, this is change in strain, that is delta epsilon. Now the slope of this line, OA line का जो slope है, that will give you the value of Young's modulus. So here slope of line OA will give you the value of Young's modulus, and this is equal to del sigma by del epsilon, and this is the measure of stiffness. कैसे? As the value of Young's modulus rises, means higher value of stress is required for the same deformation, right? Now the third one is toughness. So let me write it here. Toughness. This toughness is given by the area under the curve. Area under curve up to the point G, that is the fracture point. This is actually stress into strain. So in terms of unit, if I write it, then it will be Newton per meter square, and strain is unitless quantity. So this can be written as Newton meter per meter cube, and that is equal to joule per meter cube. Means this much of energy is required per unit volume to fracture the material, and this is given by the area under the curve from the point O to the point G, right? Now the last one is ductility. So let me write it here. Ductility, this is actually elongation strain up to the fracture point. Fracture point is the point G, and let me draw the vertical line at this point. So this point, इस G point से जो मैं vertical line draw करता हूँ, it is striking on the straight line at the, and this is the fracture strain. And ductility, we can say it is elongation strain at fracture point. At fracture point, that is G. नाउ अब इसके बाद में हम इसे फर्दर और इलेबोरेट करते हैं. तो हमने फर्स्ट फाइंड आउट किया था स्ट्रेंथ. सो स्ट्रेंथ, लेट मी चेंज द कलर ऑफ दिस पेन. व्हाट इज स्ट्रेंथ? After our analysis, we can say strength is the ability to resist plastic deformation. Ability to resist plastic deformation. What is stiffness? Second point. From our analysis, we can again say stiffness is the ability to resist elastic deformation. And what about the ductility? Now about the ductility, we can say this is ability to undergo plastic deformation. right? Okay, so this was the advanced analysis of stress strain curve for ductile material. आई होप ये वीडियो आपको प्रॉपर्ली समझ में आया होगा, बट स्टिल अगर आपके मन में कोई डाउट है देन यू कैन आस्क मी एट द गिवन कॉन्टैक्ट नंबर एंड जीमेल आईडी। तो अगर आपको ये वीडियो पसंद आया तो डेफिनेटली इसे लाइक कीजिए और अपने फ्रेंड सर्कल में भी इसे सर्कुलेट करें ताकि बाकी लोग भी इसका फ़ायदा उठा सकें। थैंक यू।